Hello everyone. Today I am solving this problem binary subsequence. So in this problem we have a binary string s of length n, and binary string simply means that it has only two characters, and it is stated in the question that every character is either 0 or 1, and we are required to erase some elements from the given string so that what we are left is only a non-decreasing string, and it means that there should be no 1, that is no character 1 present before any character 0. As you can see that this is not a valid case because we have two ones present before 0. This is a valid case, and this is also not a valid case because we have few ones which are present before zeros, and so on. So as we can see in this example, the minimum operations required to make this a non-decreasing string or a non-decreasing subsequence are 0, because this string is already valid, and then we have 110. Now this is not valid, and we can remove the 0 to make it only 11, which will be a non-decreasing sequence, and therefore answer in this case is 1. And then we have 10101, and we can remove these two zeros, that is one is this one and then this one, and this will make it a non-decreasing string, and therefore we can say that answer for this case is 2, and so on. So this is the problem statement, and from the constraints we can also see one more thing, that sum of n does not exceed 10 raised to the power 6, and it means that the solution actually requires time complexity of order of n. So that's the hint from the constraint, and let us now try to understand the logic to solve this problem. So we will look at this example later, but currently let us take an arbitrary string 0, 0, 1, 1, 1. Now this is definitely a valid string, and what we can observe from this string is the fact that every valid string has some transition point, that is, or some transition line or boundary before which every element or every character must be 0, and after which every character or every element must be 1. Because if there is any 0 here, or maybe here, or maybe here, then in that case we are actually violating the rules which are given to make this string actually a valid string. That is, after boundary every element must be 1, and before boundary every element must be 0. So this is the one observation we have from the given example. Now there could be other cases as well when all the given characters in the string are zeros. In that case we have no such transition point or boundary, or we can say that we have a boundary here after which there are 0 number of ones. And similarly, if all the characters given are actually 1, in that case we have a boundary here before which there are 0 number of zeros, and after which there are some ones. So let us not get into that currently, and let us just focus on this example. So we have 0, 0, 1, 1, 1. Well, we can see that it is possible to actually make a boundary here, but it is not possible for our computer. Suppose that it made a boundary here, and if it do so, then in this case how many zeros are required to be removed from this sequence? Well, the answer is only one, that is this one, because it is the only 0 that is present after this boundary. So in that case the cost will be 1. Similarly, rather than making boundary here, we could have had a boundary at this point also, and in that case we can see that there are no ones present on the left and no zeros present on the right, therefore cost is 0. So this is the better option. If we have this as the boundary, then how many ones do we need to remove? Well, there is one on the left, and therefore cost of removal from the left side is 1, and there are no zeros on the right, therefore total cost is only 1. Similarly, we can make our boundary here, and in that case how many ones I need to actually remove? Well, I need to delete 2 ones. So the cost from the left is 2, and there are no zeros on the right, so the overall cost in this case is also 2. And now if I make the boundary here, in that case after this there are no zeros, and before this we have 3 ones. So if I want to make a boundary here, then in that case the cost is 3. So we know that the best possible cost was 0, therefore it is our answer. Let us now look at this problem. Again we have the same problem, and this is my boundary and this is my current element. So before applying that procedure, we can actually remove all the zeros that are present in this binary string. And how many zeros are there? 1, 2, 3, 4 and 5. So there are 5 zeros. So one possible answer is 5. And there is one more possibility that I can erase all the ones present, and in that case answer will be 4. So I can see that better option is 4. So I'll decrease this and make this equal to 4. Now let us see the working of the procedure. And initially I have this boundary here when I am at element 0. And if I check how many elements are actually required to be erased from the left, well, there are no ones present on the left. And how many zeros are present on the right? There are 1, 2, 3 and 4 zeros present. So in that case, if I make this as the boundary, answer is 4. And yes, the answer was previously 4 as well, so there is no change. Then I'll move forward, and now this is my new boundary. In this case, how many ones are present before this boundary? 0. How many zeros are present after this boundary? 3. So I have a better candidate for the answer, which is 3, and therefore my new answer is 3. Again I move forward and I see how many ones are present before this boundary? Only 1. And how many zeros are present after this boundary? 3. So in that case 3 plus 1, that is I am going to erase this element, this 1, and I am going to erase these 3 zeros to make this 0 0 1 1 1. In this case the cost is going to be 4, which is no better than 3, and therefore I am going to ignore this value. Again I will move forward and again I will see how many ones are present on the left. Only 1. And how many zeros are present on the right? 2 zeros. So 2 plus 1, 3, which is not better, so there's no point in actually changing this, so it remains the same, that is 3. And after this again I'll move to the right. How many ones are there on the left? Well, there is only 1 1. And how many zeros are on the right? There is only 1 0. Now I can see that 1 plus 1 is equal to 2, that is removing or erasing 1 1, that is from here, and removing or erasing a 0 from the right, which is here. This will make cost equal to only 2, which is less than the current answer, and therefore it is time to update this value. Again I'll move right and I'll see that how many ones are actually needed to be erased from the left, 2, and how many zeros, 1. So in this case cost will be 3, which is not better, therefore my cost remains 2. Again I'll move to the right. Again I'll see how many ones are on the left, 3, how many zeros are on the right, 1, and so on. Anyway, this is going to be the best cost, and therefore this is our answer. So this is how easy it is to solve this problem, and to actually simulate this case all we are required to do is to apply a for loop. And one thing you can think, that whenever we are counting, that is whenever we are at some point, suppose we are here and we are counting number of ones that are present on the left, do we actually need to count them one by one? Answer is definitely no. What we can do is, whenever we encounter a 1, we'll increase the number of ones by 1. That is, till now I have only 1 1 on the left, and suppose that I move to the right. Now as the current element is also 1, the number of ones increases and it becomes 2, and which is correct, that there are 2 ones on the left. And similarly we can also count number of zeros on the right, and for that what we need to do is to count total number of zeros minus zeros that we have encountered till now. So that will reveal how many zeros are on the right. Suppose how many zeros do we have? 1, 2, 3, 4 and 5 zeros in total, and we have encountered 4 zeros till now. So 5 minus 4, that is 1 0 is there on the right. So this is how we can do this, and now I think it's time to see the solution for this problem. So this is the boilerplate to solve this problem, and what I have is I am inputting t here, that is number of test cases, and then n, that is the length of the string, and then string itself. Now first thing I need to do is to count the total number of zeros as well as total number of ones for the cases when I have all ones or all zeros, and therefore int zeros initially is 0 and ones is also equal to 0. Then I am going to loop over all the characters that are available in the string. So, and if the current character is a 0, that is if s of I is equal to 0, in that case zeros increases, else ones increases. So now I'll have all the number of zeros and ones available in the string, and initially answer is definitely the minimum of these two values. After this, as we did earlier, I am going to apply a for loop to move left to right so that I'll have my boundary, and if the current element is 0, then I'll do the required. So int current zeros, so int current zeros is equal to 0, and how many current ones we have? Current ones is also equal to 0. Then I'm going to iterate over the elements. If we have a 0, that is if s of I is equal to 0, then current zeros increases, else current ones increases, and now answer is minimum of answer, comma, number of ones on the left plus the number of zeros on the right. So how many ones are there on the left? Current ones. And how many zeros are there on the right? Total number of zeros, that is zeros minus zeros on the left, so current zeros. And yes, that's it. Finally I'll print the answer and I'm done with the solution. So and yes, everything is working fine. So yes, that was the solution to solve this problem, and now I'll see you in the next video. Thank you.